Okay, good afternoon, everyone. Good morning, maybe to people online. My name is Thomas Pelzer. I'm happy to be invited today to talk about digital twinning as we, as a corporate company called Cyclomedia, are perceiving it. What we try to do basically is to visualize the outside world and how we're doing that and what kind of tech components come into play. I will elaborate while going through the slides. Obviously, the connect with TechFusion and the topics of today are also about smart, intelligent transportation systems. So I try to get my standard story a bit tailored towards your agenda here, and also try to connect maybe to touch points from the previous speaker about how certain devices are usable, yes or no, or how they can be enhanced in usage, yes or no. Before kicking off, we have this introduction video of the company, basically to okay, let's just dive into the probably it was a 2 GB presentation all in total, so maybe hardware constraints. That's also about performance, right? We need to be sure that software and hardware are up for the job. A bit of the numbers game here. So not sure who has ever heard about Cyclomedia before. Who knows the company? You have. That's one. That's already something. So basically, we have been existing for the last 14 years. We originate from the Netherlands. It's a spin-off of the University of Delft. University of Delft basically has a large footprint in the GIS world, geospatial world. And as a spin-off, we have been quite successful 40 years later down the road in implementing GIS solutions for various segments in multiple markets. We have a fleet of 70 cars today. We are mainly targeting Europe and US as markets to sell our data. Not only are we selling data, last couple of years we have also expanded on the data insight portfolio. Basically, we are detecting stuff in our imagery and point clouds, and we are bringing those detections into actionable solutions. We have 4 petabytes of data in the cloud. You mentioned zettabyte. That is a whole different level. But we are one of the largest consumers of the Azure cloud solutions, mainly because of the vast amount of images that we are collecting. We collect this year as first, we want to be collecting 1 million kilometers of road network across Europe and the US. And basically, we collect every 5 meters a set of 5 images that are in a fully automated process being stitched together as 360 panorama images. Also, yeah, a few references towards customers where our data is being used today. In a nutshell, there's 3 core components into our daily activities. It's about data collection. So this fleet of cars equipped with sensors, we call it recording systems that are patented. And basically, we have synergy found in between camera system and LiDAR sensors, basically shooting out small pulses of light. So we are collecting 2D images and 3D scans of the physical world, and we translate those into virtual representations. All these representations come together in what we call data visualization platform. We have a platform called Street Smart. You could compare it maybe to Google Street View, for example, where you can go into a map view and from map view into a 360 panorama view. We add a bit more functionality in our paid platform. And as mentioned, we also derive data insights from those core products. And what those data insights look like, I can briefly expand in this next slide. So I've bucketed them a bit in, let's say, categories that are on one side recognizable, and on the other side, from product perspective, makes sense to bring them together into one. So you see, for example, GeoObjects Plus, which is a set of 6 standard detections that we do. For example, manholes, trees, traffic signs, paint striping on the road, and 2 more. So we provide basically point locations of found detections, and you can use a shapefile into your viewer and basically click on this particular point location, and our corresponding imagery will be opening, and you can assess that found asset. We also provide area and surface mapping. Basically, we determine if something is paved, yes or no, what type of pavement is it. Because this is also in relation to digital twin use cases for smart cities very much of value. They need to know how much green space do we have, how much road network versus pedestrian facilities do we offer. So there's a bunch of them, a few more being considered about time. You can always ask me later on about specifics if you want. The next set is about text assessments, and this is maybe typical Dutch, not sure. Not all of our products are replicable towards other geographies. But basically, if you have a terrace as a barkeeper in Holland, you have to pay taxes to have this terrace in public space open for the public. Basically, we determine based on imagery if there was a terrace, yes or no, based on do we see chairs and tables and people drinking drinks. And then we've used multiple sources basically to detect the exact dimensions of the terrace and make a pre-calculated tax assessment for the tax as well. Basically, what they did in the past was going food city, food, what's it called, boots on the ground, quite labor intensive, and now we only direct them towards our found abnormalities, basically, because the non-abnormalities are found detections that are right. Basically, we are providing a low-cost value stream for customers based on smart technology. Same applies for commercial signage text. Is basically really applicable towards multiple geographies. I'm sure that in UK there's also some ban towards all kind of commercial signs. So in Netherlands we are basically text for making public announcements as such. City of Amsterdam has saved, I'm sure if I can explain this, a lot of money, basically by using this product from us. And also, not only does Amsterdam now have a lower cost on the cost side, but also they have a higher value in the income side. Plus, and that's maybe most important for the users in the end, or for the ones who are being taxed, being levied, they now get tax documents that are right, and they are paying less tax in the occasion that they were paying too much. I'm sure this comes across, but what I try to say is that in the past they could have found a tax levy that was not accurate, but still they needed to pay because that was sent to them. By now we have a objective assessment, and basically this objective assessment makes it clear to anyone involved that this is a to be levied sign, and therefore this is the accompanying tax bill that comes along with it. Also on road surface analysis, basically towards the previous speaker, we detect potholes and all kind of abnormalities in the road pavement. This is very helpful for road authorities that are equipped with or are tasked to maintain the road network, basically. So instead of going only in maintenance after a claim was made about a found pothole, we are now working towards a smarter use of the data where they can anticipate on projects to come in the future. So we are now building a data set that makes projections towards future potholes, basically. So that's, I can spend an hour just talking about this particular data insight, but in the end, the key takeaway is if you have smart data to work with, then you can make your processes more efficient, and in the end, save time and money. So next to us collecting data by cars, we are also deploying a fleet of aircraft in the Netherlands, and as of this year also in Belgium, basically to cover the entirety of the Netherlands and Belgium from the air. We have partnered with a company called Hexagon, a large company based in Switzerland, or at least headquartered in Switzerland. You might know the Leica photography equipment. So Leica also deploys hybrid sensors that we are mounting underneath aircraft. Basically, again, collecting simultaneously images and point clouds, allowing us to basically make a set of products that are complementary to the street level images and point clouds. Yeah, so not sure if you guys have heard about GSD as abbreviation, the ground sample distance. This tells something about the resolution of the imagery. So basically, 1 pixel on the ground in the image represents 2.5 to 6 centimeter on the ground. So you can imagine if you are flying at an altitude of 14,000 feet, 6 centimeter resolution on the ground is pretty impressive, given the fact that you are flying not only at a high altitude, but also at a certain speed. So the story here is that we have deliberately chosen for a top-of-the-line sensor provider because that matches our requirements that we are promising to the market. And basically, at Cyclomedia, we have this 40 years of experience and promise to the market, and this set of products need to be complementary and for the same job. So in a nutshell, we are collecting images. We do the top-down image, which is called nadir. Those top-down images, these are being stitched together into a photo mosaic, basically as an alternative to a base map display. So instead of a map display like OpenStreetMap, you can use orthophoto mosaic, which you might recognize again from Google Street View, at least from going high level to zoom down level. Except for you can zoom in much more further in our imagery, or at least maybe just as far, but you can see more because it's higher quality imagery. Then there's oblique images, which is basically a 45-degree angle in 4 wind directions. So each object in outer space is being captured in 4 different angles. And then on top of that, the aerial lidar, which is a 3D scan of the full environment, makes us able to make the promise that we can visualize the entire outer space both in 2D and in 3D. Can I ask who has worked with point clouds in the room? A few, okay. So point clouds basically is a 3D data set, which is very helpful to detect all kind of things in our case in outer space, but also very much helpful towards modeling objects in a virtual representation, read digital twins. So what we have done, basically we have combined nadir imagery, oblique imagery, and aerial lidar, and have complemented this essentially what we have done, we have created a 3D model of the entire Netherlands in a high resolution quality. And we claim this is the virtual representation as a sort of canvas for digital twin applications. So we are not saying this is the digital twin. No, it's one version of the digital twin representation. At least it's most relatable, recognizable data set from human perspective. Obviously, you can do much more once having this data set. So this particular video is a recording from Microsoft Flight Simulator, just to add some fun to the mix. But you can see how this data is being used in various applications. So we have a background in GIS. You can also use the data in game engines, or in CAD systems, or in BIM systems. Essentially, we have opted for 3 standard formats to make sure that we are compliant to most system requirements. And one of the formats is also a OGC standard, the Open Geospatial Consortium, basically making sure that we are compliant to the GIS standards of working. Now, so this canvas, this is a representation of the outer space. This is based off aircraft material. I told you that we have a strong history in collecting street level data. So we're now in a phase where we are basically merging street level content into our 3D models. We call it as a working name SuperMesh. I'm not sure if the name sticks around, but SuperMesh, actually what you see on screen here is not so much a capture with photo device, it's a rebuilt model. So you can see how, for example, the light pole is, if you look really close, you see some things that might not occur right, but it's really hard to basically mesh a organic shape. So anything that is round or even small bowl type structures are quite difficult to mesh. But having enough input material, you can basically create also good representations. Another one is, I'm not sure it is, I won't call it pedestrian ramp, but it's this much accurate that we have a sub-centimeter accuracy in the data set. And that opens up for a lot of use cases, which I will also a bit elaborate on later on. So the mission is to give access to the most realistic representation that we can build. Anything that Cyclomedia does is large scale and systematic, so we don't want to have any human intervention in the processing of the data. For example, the images that we are collecting with our cars are, while driving, also being blurred. So that's driver's licenses as well as people who have been detected. So any facial expression actually all faces are being blurred. In certain countries, it goes as far as a full body blur because legislation makes us do. Next couple of slides will be around the digital twin experience with an eye on this Supermesh. Supermesh is not yet a product, but it's something that is technically producible today and that we are intending to bring to market in 2025. At this moment, we are in the midst of a go-to-market exercise, basically to validate if the product is ready for the market and if the market is ready for the product. Because typically Cyclomedia is good at pushing technology. We have something created in our R&D and we are bringing it to the market. It's a bit like, hey, here's a solution, do you have a problem? Which is the other way around. So we are now validating what is the need of the market and how does this product fit in there. So it's around certain themes that we are focusing on. These themes have been part of this validation in go-to-market phase, where we are talking to actual customers and prospects, where they are intending to use the data. So it's about cities and smart cities and digital applications. It's about urban planning. It's about livability, making sure that people are experiencing the right life in the city. It also connects to the mobility component of digital twinning. Second is the services. It goes as far as public light poles, the utility part of it, as well as public services in terms of safety. So emergency responders are also in this bucket. And then all in the background, the IoT component, Internet of Things component, whereas telecommunications is the main driver. 5G was mentioned, so the 5G rollout and small cell antenna placement. That is where a product like Supermesh comes into play, because we know where are light poles, where are obstructions from a signal, and where can signal propagation be enforced, yes or no. Cyclomedia, so those are the themes that we are connecting to. We have a huge yearly investment round that is being budgeted around this time of the year in September. Basically, where are we spending our money in R&D? And that's always quite a challenge to get the right money allocated to your products. So AI, which is it's a bit of a container term, but anything that you can detect in an image, basically, or in a point cloud or in a mesh, and connecting those detections to other layers, sources from third parties, open data, and bringing those insights together into actionable insights, basically. So AI for us is it's a bit of a gray box, a big question mark as to how to best use AI in our advantage, basically to serve our customers. Because we don't understand all components of AI. Certain of our customers understand their domain better than we do, and ever will in that respect. So we find importance in working with partners that are experts in their domain, and those partners could be our customers themselves, but also intermediate companies. Second, platform play. So it all needs to come together into, let's say, interchangeable interface. I'm standing in front of a screen. You as a user are using a laptop, a mobile device, a tablet, VR goggles. Basically, you need to consume data or work with applications. This is the platform play. So we need to make sure that our data is not only findable, but also usable and basically working for our customers. I told you about us being a Microsoft Azure client customer, yes, but also our data is streamed towards Amazon, but also towards game engines. You can do your own local hosting. And then, okay, that's the hosting and streaming part, but then what's the endpoint? Is it indeed a laptop with a good processor and GPU, or is it a mobile phone which is maybe a bit outdated and can easily crash with heavy data? And that's the connect to Supermesh, because Supermesh is really a heavy data set. So we have gained this experience in the Netherlands with the 3DNL product. It's quite heavy already, but adding street level data to the mix, it makes the product 10 to 20 times heavier even. So that's important for us to realize. You can bring a great 3D product to the market, but if no one can consume it because the hardware is not up for it, then we are missing out on an opportunity. Or maybe hardware is up for it, but only if you pay, let's say for the high-end hardware, which is not for everyone. The other way around. I, as a product manager, my task is to make it affordable for everyone. Obviously, I need to make money for the company, but I can only make money if people are willing to spend money. So my take on it is, as cheap as I can get it to the market, better it is in terms of adoption. Next 3 slides will be around certain of the use cases that we have been validating with customers. both in Europe and the US. The story towards the UK market is around the city of Nottingham. So we are in the midst of a pilot with Nottingham City Council. Also, University of Nottingham is connected, Seven Oaks District, and a couple of more. This is part of a larger funding round where we are exploring how 3D and virtual reality can enhance citizen engagement, but even more tangible than that, not so much on engagement, but it's related to this urban planning initiative. So basically, any new build in town or any construction adjustment in Nottingham needs to be accompanied with a 3D drawing as part of the requirements for incoming requests. Since it's now part of the legal set of documents, we can make those 3D models that are coming in part of representation of the city and how it looks like. I will show a bit later on. So essentially, we are validating how urban development can profit from both data and technology. You can imagine how putting this large new build in a rural area doesn't have that much impact. Maybe from sidelines for people who are living close by, but it's not that much. But if you talk about a high rise in the midst of London, for example, there will be shadow casting, there will be loss of visibility, line of sight. There's all kind of impact that needs to be assessed before approving the plan. So our technology is helping to better make decisions on future livability in the city. Public safety, the second one, which is really relevant. We are basically proving this in various geographies and various cities. It's related mainly around large-scale event planning. So if you have a large event happening in town, where in this instance is the city of Nijmegen, it's a historic town. Once a year they organize the Walk of the World. Basically, hundreds of thousands of people are coming to the town to walk for 4 days in the vicinity of the town. Very, very cool, but even cooler are all the festivities around this Walk of the World. So the town is 7 days long, the midst of the center of partying in the Netherlands. More than 1 million people are coming to town. And this is a relatively small town. So public services are looking into a way to basically have a means towards crowd control, crowd management. So we are validating together with emergency responders how a certain set of let me redefine. So there's various party locations in town. There's from all kinds of directions people are coming in, and we need to keep it safe, essentially. Safety comes with pressure of being too crowded, or there's too little space for the amount of people that are coming there. So essentially, we are trying to have scenario planning in place for the scenarios where there's too many people in one place. We need to get people moved to different locations. There might be a certain incident of I don't know, like a bomb explosion or whatever. So this is theoretical, luckily, but we are working with scenarios basically to train emergency responders in real life situations. Also, we see that a lot of the police force from different cities in the Netherlands are coming for this 1 week to the city of Nijmegen, but they don't know the city. So having a 3D representation of the city on screen is very helpful for them to orient themselves in the city that they normally are not working in. This particular video, and I will try to push the play button on the right bottom side here. So this is a use case where there's a physical divider, a concrete pillar, and a pop-up bar as part of the facility. The fire department wants to know, is there enough clearance for me to go with my fire truck in between this pop-up and the physical barrier? Essentially to get clearance from for the safety of in case there's a fire and they need to pass it on. So you could see how in this instance there's a 332 meter width, which is great. They need to do 70, I believe. You could argue, does it need to be assessed upfront, yes or no? Well, in this case, yes, because this pop-up bar is part of thousands of pop-up bars in town, and they will be placed exactly as they have been drawn. So if the drawings are incorrect, then the placement in reality will be incorrect. So we do assessment upfront based on virtual representation before setting this all up, as well as obviously there will be a validation towards the real life situation after it has been built up. Is this indeed the 3 meter 32 width? And essentially, I mentioned we have sub-centimeter accuracy. We see indeed no larger than 1 centimeter deviations in between what was scheduled, drawn, and approved versus what was built in real life. So this is about public safety. The component was the fire department and the emergency responders. There's also the component around crowd management and crowd control. So essentially, what happened in this particular case, and it's hard to see because it's a 3D drawing, is on the edge of a riverbank. There's a large stage here, and certain pop artists are coming to play for free. And Dutch people, it's free that they come en masse towards this hotspot. There's a gated area and an ungated area. And basically, there were too many people in the fenced area, so it was getting too crowded. To the point where emergency responders wanted to have basically an evacuation plan in place to get people out of there because it was getting too crowded. This could all have been prevented when we had instead of 2D drawing, a 3D mock-up of this particular place, because then we would have understand the line of sight implications of this very location. Because the fenced area, it was fenced well, but the unfenced area was a bit higher, making that people from the unfenced area could look over the fences onto the stage. Basically, again, a scenario that was not envisioned, but became reality. And since it's really important to have these large masses of people distributed well over the town, or in this case, the next example would be a particular facility area. Making sure that we are capable of delivering on the promise of keeping it safe. So that's where the data comes into play. This next video is an impression of what we are doing as part of this field lab in Nijmegen. So we're working together with several companies and organizational governmental bodies like police, fire department, but also some nationwide organizations who are looking into basically productizing digital twin applications, but then not commercially. So it's from a governmental point of view. There was a concept from Red Hot Chili Peppers, which was hosted in a large park in the city of Nijmegen. Basically, this cross-functional team from various companies, from various organizations came together basically to validate a thing or two in relation to this concert. So we have built a 3D model. We have placed not only the stage, but also the fences, the toilets, ticket booths, anything that was relevant there. We also use SuperMesh in relation to understanding the context of the reality. Essentially, we are trying to get, from a GIS perspective, this centimeter accuracy in place. We are using technology like augmented reality, basically to see if what was built is reflected well in drawings or the other way around. We are using sensors to monitor pedestrian streams. Basically, all comes together in this pilot or field lab, as you call it, to validate multiple things. Essentially, the key takeaway was making smart use of technology and data. The event is safer, and with a safer event, you also have happier visitors, basically. So there was no concerns about safety whatsoever. But you can imagine with 60,000 people on one field, it can get easily it can go wrong, right? So having these measures in place is quite important. Just as a proof point that we are not just trying to sell products at Cyclomedia. Obviously, again, we are a commercial company, but we are trying to do the right thing for our customers and our markets. This next example is maybe a good example of what was not working that well. So basically, there's multiple hotspots in town, and over the course of 7 days, we have tried to use sensor input data to visualize where or how crowded it was in certain spots. In this particular case, the way we have configured it was not very helpful. So it doesn't say anything about how crowded it really was on that spot. It's just giving you peaks of absolute numbers. So we'll just slide through it, as you can see how days or nights are counting. Essentially, you can see how certain bars pop up, get smaller, get bigger. We'll just let it go. So smart use of sensors, yes. Smart use of visualization tools, no, because this is really not helpful. But having more sensor information, for example, for this location, we know how this graph was built. So we know based on certain sensors where pedestrians were coming from, what direction, and how crowded it was, how many people on 1 square meter, for example. Again, it's also done about using the right visualization tools, essentially. So good example, but not the best representation for this particular purpose. Go to the next slide. Example of a city of Alkmaar in the Netherlands. They have this live digital twin application for all of their inhabitants. You see the 3D product as one of the data layers that can be visualized. And you see on the left side certain menu bars or themes even where they have built their viewer around. So it's it's about mobility, it's economics, about climate. There's environmental sensors. There's all kind of things that are hooking into this platform, also by trial and error to find out what is working, yes or no. But basically already to open up towards their inhabitants, basically to enforce a better citizen engagement. And we see not only in Alkmaar, but there's by now we have out of 300, 160 local governmental customers for this product, where they are bringing multiple open and closed data sources into a viewer application. And obviously they have their own closed sources as well. So for example, they know in a building, we don't have that information, but to the level where how many people are living there, is it a family, are they having kids, yes or no? There's all kind of building information that they would have in their own subsystems, which we don't have, but where we are connecting to. Another example is the city of Zwolle. They have done a similar thing, and basically they are also experimenting with bringing input data from inhabitants themselves towards the platform. So, for example, I have a wall mount e-charge box for my electric car. I'm opening up for others to use it as well, so I can make I can put my electric charge station in this particular viewer and open it up for others to use. Obviously, there's much more to it because you have to have a billing system in place and it needs to be accorded with the facilitator. But essentially, the interaction in between municipal accounts and inhabitants, we see it more and more lifting off. And on usage by corporates, this is a company called Next. They have applications called Next, the company is called Parallel. They have a app for architects, basically to have new build plans in the context of the architecture. So a new build basically is being visualized in the context of the surroundings. Also here we see 3D now bringing value because until now they have worked only with artist impressions on one side or with shoebox type of representation of buildings on the other side. So we do see that there's not only let's say a nicer visualization tool in place, but it really brings value because you can better understand the actual impact of new builds. While we're exploring with 3D data in 2D viewing applications, we are also experimenting with 3D in 3D. So essentially, anyone who has never had the opportunity to wear a VR goggles and look at a 3D scene in 3D, whenever you have the opportunity, please do this because it is really much more immersive. I remember the first time I was looking into my product 3DNL in a 3D setup. It was quite a different experience than it was on screen. So 3D in 3D, so you think then about VR goggles, which is one way, but you have also, for example, stereo monitors. So in the midst of an experiment, we have 3D data in 3D monitors. Essentially, some of our premium brand cars already have 3D display panels in place. So you can see how more and more 3D technology in the hardware side is coming to life anyway. So it becomes more and more a commodity of using 3D data, not only in 2D, but also in 3D hardware. What it looks like in VR, so the City of Nottingham is also experimenting together with us and Esri and University of Nottingham in VR, and I have a video that will show this a bit more. But in the context of this Nottingham pilot, it's part of a multi-phased project funded by the UK government, basically to have the urban planning tool come into a daily part of the processes in the city, and not only then in Nottingham, but hopefully later on also in other UK cities. This is what they were having until Cyclomedia came into the mix. So as an aerial data provider, they work with Blue Sky. I think you all know Blue Sky also from their aerial data supply towards Ordnance Survey. Basically, Blue Sky is providing them the aerial data that they have been working with until now. Also, there's open source material like the LOD buildings you see here, and as part of the urban planning tool, the pop-up models or the models that they implement there. So essentially, what they were looking into was, can we provide an environment where our inhabitants have a better impression about the impact of these new build plans or any construction in town. And this already is helpful because it gives context. You see obstructions from existing buildings. Not necessarily can you really resemble the building that you are standing next to, but that is where the mesh products come into play. But this was in phase one. Basically, okay, we have existing sources, we have the planning tool providing us with a 3D model. How can we merge them together into an application that is part of the daily processes? You can also see how they are working with, in this case, SE software, basically to implement certain standard functionalities in there. Also connected to CCTV or other sources for that matter, where they can provide, can derive information from. I think the video is towards the end. Let's play it fully. So this is then where the Blue Sky data from aerial mesh perspective comes into play, already adding much more visual context than the shoebox models did. So I do think, I'm a bit biased, but I do think that reality capture data is indeed providing much more context. So as part of the UK go-to-market discovery, we have teamed up with Blue Sky as part of the Hexagon ecosystem subcontractor list, as they are flying with the same CityMapper2 sensor that we are working with in Netherlands and in Belgium, and is actually one of the flagships of the Leica product portfolio. So having Blue Skies collecting aircraft data, having Cyclomedia collecting street level data, and we're merging it together in this super mesh product. Not sure how I'm in time because I'm going towards the end of my presentation. Just a video left, which is about this urban planning tool, super mesh, virtual reality, and actual use case around urban planning in VR. And if all works well, this video will show how this is already working now today, and I can elaborate a bit more later on how it will be working tomorrow. So essentially, you see here the ideal combination of viewing capabilities, data from different sources, and then also tailored towards, let's say, user stories or user profiles within the city council. So not every department has the same needs for information at any given point in time. But you have to have the metadata, for example, in terms of building information, you have to have it all in the background. It needs to be clickable, needs to be findable. But you can see here, having a street level perspective of the same area of interest around this new build gives you much more context towards the impact of such a plan. You now have, okay, trees might look a bit odd. Again, organic shapes are really difficult to mesh, but having the trees reflected as per reality gives a different impression, maybe even a better impression than abstract model of a tree. These for the buildings or any road furniture that we see here, it's never to be found in the level of detail representation. And also having technology at your disposal, you can do impact analysis that's going beyond what you have seen and captured while driving along. So obviously we are here connecting to our own weather forecasting, but you can do actual live weather as one component, but use sensor information from pedestrian streams or from public transport. You know where the buses are exactly. Having all these sensors connected to this one digital environment, whereas this is always a canvas, like your 2D map in the past, this could be your 3D map of the future. And we are convinced that 3D will be more and more a commodity. And it will take time before it is indeed commoditized as such. But in the end, if you have something like a 3D mesh product, not to say ours, but something like a 3D mesh product, bringing those components together and basically we're stepping into the future and stepping beyond the 2D workflows that we have seen in the past for the last decades. We are preparing ourselves for the future. The future will be around 3D and bringing technology together. So I hope at least that the story for today was a bit insightful towards how data can be used. For each of the products that you have seen pass by, we do have extensive trainings anyway. So I'm happy to share more insights if you have questions about light poles and how we detect them, or even how we process LiDAR data. There's that much things that I would like to talk about, but I just try to be at least a bit inspirational for today.